Hello everyone. Today we'll do the derivation of electric field on the axial line of a dipole. We'll start by making the figure, that is minus q charge plus q charge. This is point A, this is point B, and the distance between the dipole is 2a. So we'll consider a dipole with charge q and separation 2a. So we'll take a point exactly from the center of the dipole to point P. We'll assume a charge at point P at a distance r from the center of the dipole, that is this. So now the electric field due to the charge at B will be directed towards this direction because we have assumed a very small positive charge at P. And due to A, it will be directed towards this direction, that is EA. Also, the dipole moment of the dipole is P, that we know is equals to Q into 2A. So now we'll start with the derivation. So electric field due to charge at A will be equals to KQ upon R plus A square. That is the distance between charge at A and the distance between charge at P. That is R plus A. This and the direction will be along PA. Similarly, electric field due to charge at B will be KQ upon R minus A square. R minus A, that is this distance, along BP, that is towards this direction. So to find the net electric field, we'll subtract EA from EB. So it is equals to KQ upon R minus A square minus KQ upon R plus A square. Taking KQ common, we get 1 upon R minus A square minus 1 upon R plus A square. Taking the LCM, we'll get R square plus A square plus 2AR minus R square minus A square plus 2AR upon R square minus A square whole square. So these two gets cancelled. So we are left with KQ into 4AR upon R square minus A square whole square. We can also write it as 2KR dot 2A into Q upon R square minus A square. And as we know, this 2A into Q is the dipole moment. So the final electric field is equals to 2kr dot the dipole moment P upon R square minus A square whole square, and the direction is along BP. I hope the derivation is clear. Now we'll take a special case in this. So we have a special case, that is when r is greater than equals to a. So basically a becomes 0. So it becomes E is equals to 2kr dot p upon r square whole square, which is r to the power 4. So the final electric field in the special case becomes equals to E is equals to 2kp upon r cube. So this is the special case of electric field on the axial line of a dipole. So this was it for this derivation. I'll see you in the next derivation. Thank you.